So a little bit of exploration to talk about our second learning target of the day. So if we were to talk about what we just learned, these are the same base, so we would write the base. Difference here is the sevens, they're not more in the top or the bottom. They're the exact same. So 7 to the 0. Well, what do we know about this? Anything over itself is always equal to 1. So obviously 7 over 7 and 7 over 7, that would be equal to 1. Therefore, 7 to the 0 has to also be equal to 1. In the second example, similar situation. What did we just talk about? When you have x's in the numerator and the denominator, we try to look where there are more. There are no more in the numerator or the denominator. In fact, the difference is 0 between them. And if we were to write that out, the original problem, you can see this is 1, this is 1, this is 1, this is 1. Therefore, this would be equal to 1. So x to the 0 power is equal to 1. So the conclusion is anything that you have, when you raise it to the 0 power, is going to equal 1. That's the easiest thing. Anything to the 0 power equals 1. The other reason, if I can fit it in here, I don't know if I can. Like you could do 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0. 2 to the 3rd is 8, 2 squared is 4, 2 to the 1st is 2. Each time you're dividing by 2. So 2 to the 0 would be 1 to continue that pattern. You're dividing by the base, which is 2. So anything to the 0, again, is equal to 1.